Dear students, yesterday we have solved this particular question. Let us revise it. Calculate the pH. We need to find out the pH of a solution of acetic acid with concentration 0.05 mole per liter, in which from outside 0.05 mole per liter acetate ions are added. The Ka value is given, that is K is equal to 1.5 into 10 to the power minus 5 for CH3COOH. So now let us find out how we can solve this problem. The various data that is given, K value is given, concentration of or initial concentration of acetic acid is given, extra added solution has the concentration that is given, and we know that C alpha, where X is equal to extent of ionization, X is equal to C alpha. C is the initial concentration and alpha is the degree of dissociation. We know that CH3COOH ionizes into CH3COO minus and H plus ion. Initially, if we look at, we will come to know that the concentration of CH3COOH is 0.05 mole per liter. Now the concentration changes, so the concentration of reactant decreases by minus X and concentration of products is increases by plus X. So at equilibrium, we will have the concentration which is the sum of these two, that is 0.05 mole minus X, and this is 0 plus X, that is X, and 0 plus X, that is X. Now at equilibrium, what happens? We add this CH3COO minus ion or acetate ion. So we add this ion which are extra. As we add these ions, my dear students, the concentration of this ion becomes 0.05, and then extra added CH3COO minus ion, which are the concentration was at equilibrium, it was X, and 0.05 molar we have added extra. So now we can put the concentration for CH3COOH as 0.05 plus X. CH3COO minus also for 0.05 plus X. For CH3COOH we can put 0.05X, and for H plus we can put X. So we have these values: 0.05 plus X multiplied by X divided by 0.05 minus X. Now compared to 0.05, X is very small because the K value which is given is of the power of the order of 10 to the power minus 5. And thus, my dear students, due to this, we can write 0.05 plus X or 0.05 minus X is equal to 0.05, and we also put the value of K. So 1.8 into 10 to the power minus 5 is equal to X into 0.05 divided by 0.05. So we have the value of X is equal to 1.8 into 10 to the power minus 5. Now, my dear students, we have got the value for X. So we can find out the pH because the concentration of H plus is given in the form of the X. So H plus is equal to X, that is 1.8 into 10 to the power minus 5. So pH is equal to minus log of 1.8 into 10 to the power minus 5, that is log of minus log of 1.8 minus log of 10 to the power minus 5. So it's 5 minus 0.26, that is 4.74. So this is how we can calculate the pH. Now we have the next question to learn about. Let us move and understand this next question. Let us see what is written in the question itself. So let me read the question for you. Calculate the pH. Calculate the pH of a 0.1 molar ammonia solution. Calculate the pH after 50 ml of this solution is treated with 25 ml of 0.1 molar HCl. The dissociation constant is given. So it's a very, very interesting question, my dear students. First, they have given you the 0.1 molar ammonia solution, and we need to find out the pH. Remember, ammonia is actually a base. So first we need to find out the pOH. From that we can find out pH. Please remember this. Then second, in this solution, after some time we add 50 ml of in 50 ml of this solution we add 25 ml of 0.1 molar HCl solution. So neutralization takes place, and at that time also we need to calculate the required things. Here they have given the value of dissociation constant, and that is given as a Kb. So now we can understand. Let us first find out the pH of the solution. Ammonia, when it is added to water, it gives NH4 plus and OH minus. Initially the concentration is 0.1 molar for ammonia. The change we can see, it is minus X for the reactant and plus X for the product. So the equilibrium concentration would be 0.1 minus X, and for products X and X. So by putting this value, Kb is equal to X into X divided by 0.1 minus X, but 0.1 is quite bigger than X, because if you look into the Kb value, it is of the power of 10 to the power minus 5. So we can write 0.1 minus X is approximately 0.1, thus Kb is equal to 1.77 multiplied by 10 to the power minus 5. So here we get the value for Kb is 1.70, the value of Kb is already given. So we can put this value of Kb 1.77 into 10 to the power minus 5. Thus we get X into X, X square divided by 0.1 is equal to 1.77 into 10 to the power minus 5. Thus X square is equal to 1.77 into 10 to the power minus 5 multiplied by 0.1. Now 0.1 is nothing but your 10 to the power minus 1, and thus we have the value of x square. So x square is equal to 1.77 into 10 to the power minus 6. Ultimately you can write x is equal to square root of 1.77 into 10 to the power minus 6. This minus 5 plus minus 1 is equal to minus 6, and thus your x is equal to 1.33 into 10 to the power minus 3. So now you have the concentration of OH minus, which is 10 to the 1.33 into 10 to the power minus 3. We know that Kw is equal to H plus into OH minus, which is having the value of 10 to the power minus 14, and thus we can calculate the value of H plus, which is 7.51 into 10 to the power minus 10. Using this value for the concentration of H plus, we can calculate pH. pH is equal to concentration of H plus, which is 7.51 into 10 to the power minus 12. On the basis of that, we can find out the pH 11.12. Now here I have one very important thing to tell you, my dear student, that when we multiply the given molarity, when we multiply the molarity M with the volume given in ml, please remember, volume given in ml, we get millimoles. So why is it so? Let me explain you. See, milli means 1 upon 1000. Molarity, that is mole per liter. Now moles, 1 mole is equal to 1000 millimoles, and 1 liter is equal to 1000 milliliters. These thousands and thousands get cancelled, and you get millimoles and milliliters. But when you get millimoles and milliliters, when you have the volume that is given in milliliters, then you have this molarity or moles given into the millimoles. So when you multiply the molarity with ml, you will get the millimoles, and you know that very well, that moles per liter is equal to molarity, and therefore mole is equal to molarity multiplied by volume or liter. So moles is equal to molarity multiplied by liter, but if you multiply, instead of liter, if you multiply it with the ml, then moles turns out to be millimole. So please remember that when we multiply the moles or molarity with the ml volume, we will get millimoles. So this is how, my dear students, you can even easily understand that now molarity is equal to millimoles divided by ml. By cancelling 1000 and 1000, what we get? Millimoles divided by ml. That is molarity, and therefore molarity multiplied by ml will give you millimoles, and this millimoles we represent as a mmol. Now we mix 25 ml of 0.1 molar HCl with this solution. So millimoles of HCl is equal to 25 multiplied by 0.1, that is 2.5 millimole. We have this solution of 50 ml of 0.1 molar ammonia solution. So when we have 0.1 molar 50 ml of ammonia solution, we can find out the millimoles. So by doing the required calculation, the millimoles of ammonia solution is equal to 50 multiplied by 0.1, that is 5 millimoles we can get for ammonia. Now my dear students, the neutralization reaction takes place between the ammonia and HCl. So NH3, when it reacts with HCl, it gives NH4Cl, NH4 plus and Cl minus. Now the initial concentration for NH3 is 5.0, for HCl it is 2.5, but the change that is takes place now, ammonia is more, so it uses all this HCl, and thus all my 2.5 millimoles of HCl is being used. If the so all these are, so the reactants are consumed, so we put minus 2.5, and products are produced, so we put plus 2.5. Ultimately this finally the millimoles, if we calculate, the millimoles that we find is 5 minus, this is minus 5 minus 2.5, here 2.5 minus 2.5, here 0 plus 2.5, 0 plus 2.5, and here also 0 plus 2.5. So finally we will get 5 minus 2.5, that is 2.5. The concentration of HCl is 0, the concentration of NH4 plus is 2.5, and the concentration of Cl minus is also 2.5. Remember, we get this concentration in millimoles. Now my dear students, we want to calculate anything, we need concentration in mole per liter, and that is what we write it, molarity. So we need the volume 1 liter. So we mix 25 ml HCl with 50 ml of NH3, total volume becomes 75 ml. We have mixed 25 ml and 50 ml, so total volume becomes 75 ml. So now the concentration of ammonia is equal to 2.5 millimole divided by 75 ml, that is 1 by 30 mole per liter. This is 1 by 30 mole per ml. Please remember, this is 1 by 30 mole per ml, which is equal to 0.033 molar. That is what it gives us in the 1 liter. So please remember, my dear students, that this 1 ml, one ml is equal to 1 upon 1000 liter. 1 ml is equal to 1 upon 1000 liter. 1 ml is equal to 1 upon 1000 liter. So if we put 1 by 30, this, therefore 30 ml is equal to 30 upon 1000 liter. So we can put 1 upon 30 divided by 1000, that is 1000 divided by 30, which gives us the value 0.033 mole per liter. Same way, my dear students, for NH4, now we want to find out for NH4 plus also we get 22.5 millimole divided by 75 millimole, that is 0.33 mole per liter. Now the undissociated ammonia gives, or no neutralized ammonia gives us OH minus as follows. You can see that, my dear students, that during the neutralization process we still have 2.5 millimoles of ammonia left with us. This 2.5 millimole of ammonia left with us, which reacts with water to produce OH minus. This 2.5 mole of ammonia is nothing but your 0.033 mole per liter ammonia. So this is the initial concentration. At equilibrium we will get the concentration 0.033 minus Y, and the NH4 plus and OH minus produced are YY moles per liter. This also represents the mole per liter. Now we know that in total we have 75 ml of solution. Total concentration of NH4 plus would be 0.033 plus Y. Now this is also interesting to understand, my dear students, that we have already concentration of NH4 plus, which is produced by the neutralization. So here we have already the neutralization takes place, and due to neutralization, my dear students, the concentration of NH4 plus that we have obtained is 0.033. Now here also, if you look into this concentration of NH4 plus which we have is 2.5 millimole. So when we look into this, my dear students, this concentration, which is 2.5 millimole, gives us 2.5 millimole, that gives us 0.033 mole per liter, and the new concentration which is produced by the undissociated NH4 plus is Y mole. So total concentration of NH4 plus is equal to 0.033 plus Y. Dear students, do you understand this? If you don't understand, please don't feel shy to ask me. Let me explain it to you once again. If you look into this, my dear students, the total concentration of NH4 plus taken from here, this NH4 plus as well as this NH4 plus. So when this reaction takes place, we had 5 millimoles of an ammonia that is being utilized, and we got 2.5 unreacted. This 2.5 we have converted into 0.033. This NH4 plus when it reacts, this NH4 plus when it reacts, so we have 0.033 mole per liter of ammonia. Then this undissociated, when it reacts with water, it produces NH4 plus and OH minus. So the extra concentration we get is Y mole per liter. So this is how the total concentration of NH4 plus ion is equal to 0.03 plus Y. Please remember that the total concentration of NH4 plus that we get is 0.033 plus Y. But we know that Y is quite 0.03 quite smaller than 0.033, and therefore for 0.033 we will approximately write 0.0 for 0.033 minus Y, we will approximately write 0.033. Now we want to find out, or we want to calculate the concentration of OH minus. We know that from this equation the concentration of OH minus is Y, the concentration of NH4 plus is 0.033, and the concentration of the concentration of NH3 is also 0.033 minus Y, which we approximately take it as a 0.033 because the value of Y is quite smaller than 0.033. So my dear students, we can put all these values for the concentration of NH4 plus, OH minus and NH3. So finally we get here that Kb is equal to 0.33 multiplied by Y divided by 0.33. Thus Y is equal to 1.77. The value of Kb is 1.77 into 10 to the power minus 5, which gives us the concentration of OH minus. Now my dear students, the concentration of H plus and OH minus, by multiplying them with each other, we get 10 to the power minus 14. This is what it is known as the Kw, and thus the concentration of H plus is equal to 10 to the power minus 14 divided by the concentration of OH minus. Thus we get the concentration of H plus as 5.6 into 10 to the power minus 10. Now we have the concentration of H plus, so we can find out pH. pH is equal to minus log of H plus, that is minus log of 5.6 into 10 to the power minus 10, which gives us the value of pH 9.24. Now my dear students, if you could not understand anything, you can ask. बच्चों अगर कुछ समझ में नहीं आया तो पूछ सकते हैं. Shall we move forward? आगे चले. क्या आप लोग मुझे सुन पा रहे हैं?
Yes, sir.
Can I have a reply from you, my dear students? Can you hear me?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, shall we move forward?
Yes, sir.
Thank you. Okay, then let us now see some new topic, which is known as the hydrolysis of salt and pH of their solution. Hydrolysis of salt and pH of their solution. It is very interesting. Let us study it well. Salt formed by the reactions between acids and bases in definite proportion undergo ionization in water. Process of ionization means converting themselves into the ions. So when the ions are formed, we have cations, we have anions are formed. The cations or anions formed on ionization of salt either exist as a hydrated ion in aqueous solution or interact with water. Now my dear students, you know that we have seen that whenever the ions are formed into the water, water molecules surround those ions, and when water molecules surround those ions, like we have seen in case of NaCl, that there were NaCl, and around that NaCl there were various molecules of water surrounded NaCl, and this is what it is, the process we have called it as the process of hydration. So your positive ion or negative ion is surrounded by H2O molecules. and this process is known as hydration. So due to hydration, my dear students, the the ions are surrounded by the water molecules and energy is released. Energy releases. So with water, so these ions which are formed, they have, whether they are positive ion or negative ion, these ions which are formed, they undergo two different processes. One process is known as a, one process, my dear student, is known as a, one process is known as hydration. The another possible process is known as hydrolysis. Let us see. So when these ions, when they react with, so if these ions are not hydrated, or these ions can react with water, when they react with water, they reform the corresponding acids or bases depending upon the nature of the solid. So let us understand this. What we have read, just let me show you with some kind of mind map. Let us look into it. My dear students, let's have a look to this. Suppose we have salt. This salt is made up of cations and anions. So when we add it to the water, it forms the cations, it forms the anions. So we have now these ions. These ions undergo two different processes. One process is hydration, another process is hydrolysis. In process of hydration, my dear students, those ions which are produced from the strong acid or strong base, those ions which are produced from the strong acid or strong acid or base, those ions which are produced from the strong acid or base, they undergo the process of hydration, so the water molecules surround these ions. But these ions, which, that is the cation from the weak base and anion from the weak acid. So here if you look into the cations, these are the cations from the strong base, and these are the anions from the strong acid. So these are the anions, these are the cations. So what we can simply say, cations from the strong bases and anions from the strong acids, they undergo only hydration. But the cation from weak base and anion from weak acids, they undergo both the process which are known as the hydration as well as hydrolysis. But remember that the cation from strong base and anion from strong acids, they do not undergo hydrolysis. The hydrolysis takes place only in case of the cation from the weak base and anion from the weak acids. So my dear students, the cation from the strong base will not undergo hydrolysis, but cation from the weak base will undergo hydrolysis. Anion from the strong base will do not undergo hydrolysis, but anion from the weak acid, they undergo hydrolysis. Please remember this. And my dear students, this salt is formed by the reactions of acid and base. Salt is formed by the reactions of acid and base. So we have various types of salt that we have studied. We can have acidic salt, basic salt and neutral salts. We will study them in detail, don't worry. Now let me read the next text for you. So my dear students, the hydration, what is hydration? Let us understand. We are going to study here about the hydration. When a salt dissociate or ionizes, when a salt which is ionic dissociate, so ionic salt dissociate or covalent salt ionizes. So when a salt dissociate or ionizes, when added to water, the product ions are surrounded by water molecules. This process is known as hydration. So the ions which are surrounded by water molecules, this process is known as hydration. Hydration facilitates ions to move freely into the solution. Ions remain well spreaded due to the hydration. This is the speciality of hydration, that when hydration takes place, ion can move freely without affecting each other, and they can remain well spreaded into the aqueous solutions. But now what is the case? Ions which are cations from the strong base like Na plus, K plus, Ca plus 2, Ba plus 2, These ions generally form the strong bases like NaOH, KOH, CaOH twice, BaOH twice. These are the strong bases. So cations coming from the strong base and ions which are anions from the strong acids, ions which are anions from the strong acids like Cl minus Br minus NO3. So we have the strong acids like HCl, HBr, HNO3, HClO4. So these are the ions. So ions coming from the strong acids undergo hydration, but these ions do not hydrolyze or do not undergo the process of hydrolysis. So my dear students, the uh, cation coming from the strong base and anions coming from the strong acids, they do not undergo the process of hydrolysis. Cations from the weak bases and anions from the weak acids undergo a process called hydrolysis. So now let us understand what is the meaning of the word or the process hydrolysis. Let us study about hydrolysis. Cation from weak bases and anion from the weak acids interact with water and produce their corresponding weak acids or weak base. This process is called hydrolysis. So my dear students, suppose we have the cation like CH3COO, anion like CH3COO minus, that is coming from the weak acid, it reacts with water and produces CH3COOH and OH minus. So these ions produces the acid from which the salt has been prepared, and this process is known as hydrolysis. Same way, my dear students, suppose we have the anions coming from the weak base, for example NH4 plus. So NH4 plus, again when it reacts with water, it produces, my dear students, H plus and NH4OH. So this NH4OH is produced from the base NH4OH. NH4 plus is produced from the base NH4OH, which is obtained back. And this process of conversion of these ions coming from the weak base or the ions coming from the weak acid, ion coming from the weak acid and ion coming from the weak base, they produces their corresponding acids and base by reacting with water, and this process is known as the hydrolysis. Now, my dear students, here you can see I have tried to explain you the hydrolysis of salt. So let us study the various types of salts and hydrolysis. First of all, we should study what is salt. So when acid and base are mixed in a proper proportion, they give salt and water. Now we have the salts. We have three major type of salt: acidic salt, basic salt, and neutral salt. So what is acidic salt? Acidic salt has its pH less than 7. Basic salt is the salt which is having pH greater than 7. Neutral salt, we have two type of salt. First type of salt has pH exactly equal to 7, and the second type of salt has a pH that varies from 7. That we will understand. Now, my dear students, let us first understand about the acidic salt in detail. So let us look into the acidic salt in detail first. Let us study about the acidic salt. Acidic salt is a salt formed from the weak base and strong acid. For example, you can see NH4Cl. NH4Cl is prepared by the reaction of NH3 with HCl, or it is prepared by the reaction of NH4OH plus HCl, that gives NH4Cl plus H2O. You can see that NH4OH is a weak base and HCl is a strong acid. Thus we get the acidic salt in water. When acidic salt is added to water, it forms ions. These acidic salts, my dear students, this acidic salt, when it is added to water, this acidic salt, when it is added back to the water, my dear students, it forms ions, cations from the weak base and anion from the strong acid. So this NH4Cl, when it is added to water, it produces NH4 plus and Cl minus. This salt, when it is dissociated completely, So this acidic salt dissociate completely. So salt, when it dissociate completely, cation from weak base undergo hydrolysis and forms the weak base in a water. So my dear students, these NH4 plus which are produced from the NH4Cl, they react with water because they are the cation from weak base, cation from weak base. So as these are the cations from the weak base, they react with water and produces the same base, weak base from which they have been produced, and they also produce H plus. NH4OH, which is a weak base and remains undissociated into the solution, and that is what it causes the H plus. So my dear students, when this equilibrium is formed, this NH4 plus does not give the reaction back, and that is why the H plus produced also remains in the same concentration, and that is what it caused the H plus leads to the acidic solution. So as this NH4 plus does not give the reverse reaction because it is a weak salt and it remains in the solution, it does not affect the concentration of H plus, and that is why H plus remains in the solution, which leads to the pH less than 7, and it makes the solution acidic in nature. So this anion from strong acid does not undergo hydrolysis. So my dear students, you can see that this Cl minus, only NH4 plus undergoes the hydrolysis.
मुकुल सोनी, आपका टॉपिक क्या है?
टॉपिक है मैडम salts. Just a minute.
Salts.
Just a minute.